Welcome to Three Devs and a Maybe. Now introducing your show hosts, Michael Budd, Fraser Hart, Lewis Gaines, and Ed Mann.
Hello and welcome to another episode of Three Devs and a Maybe. My name's Ed Mann, and today we're very lucky to be joined yet again by Scott Wlaschin. How you doing, Scott?
Fine, thanks. Thanks for having me on.
Awesome. Well, thank you for coming on again. Calling for our archives, and it's probably been just under a year since we last had you on, which I think is criminal because I always love talking to you and always love listening to you on other podcasts and other things you do. And you seem to have been a very busy man this past year, actually. For the audience, you've recently released it's content complete, but it just needs to be officially released. But you've released a book called Domain Modeling Made Functional with Pragmatic Programmers. And I'm just wondering, kind of like to kick off, would you mind just giving a little background about the book and how it came to be?
Yeah, so domain modeling and domain-driven design is something I've always been interested in. In fact, the very first talk I ever did in public, which was actually just over 4 years ago, was on domain-driven design in F#, functional programming. And so I always thought it's a great way to sort of introduce people to functional programming, without having to talk about monads and all the weird stuff that people have. So, I was recently asked if I would be interested in doing a book by someone at Pragmatic Press. And I said, this would be a great topic. I've always wanted to talk about it. So there we go. We started the book. It's a bit of an experiment, really, because domain-driven design and functional programming are not normally something that are put together. And I'm also often, there's people who don't know anything about any of those things. So the book is sort of, the first bit talks about what is domain-driven design, and then the next bit talks about what is domain modeling using an algebraic type system like F# has. And then the third bit is actually how to actually implement all this stuff, which is where it gets complicated. And that's where people can lose track. So where you do need things like monads and stuff. But the first two parts of the book are basically very non-technical, I think.
Because I was going to say I admire you because you certainly have picked two very hard topics or very kind of alien to certain people topics to kind of meld together. And they do work really well together. And I think in the past episode we did kind of touch a little bit on this. Because I think a lot of people probably think functional is very much mathy, and then domain modeling and domain-driven design is more kind of corporate-y. And it's nice the way that you were able to blend them together.
Yeah, to me, they're kind of obvious. Obviously the functional stuff is something that people have to learn. But once you understand the concept of composition, that functional programmers always go on about composition this, composition that. And it's basically gluing things together to make bigger things. And the type system in a functional language is designed that way. You can glue things together in various ways. And it's really, really a fantastic fit for doing domain modeling. So to me, it's not something strange and weird. It's actually something that goes together really well. And again, and domain-driven design, again, I think is something that seems to have a mystique about it. And people tend to make it more complicated than it really is. And in my book, I just try to explain it's really all about communication and trying to get everyone on the same page, which is not at all mysterious. It's really common sense. So.
Well, I was going to say also, I've been reading through your book and I've read a lot about domain-driven design and quite a bit about functional. And I'd say, your books is definitely up there for me as like a great intro into domain-driven design without all the buzzwords. You start off and you really show it through the philosophy first. It kind of like distills into, so that's what that means and that's what that is and stuff. Whereas, a lot of other articles and things you'll read online or maybe other, kind of material, it will go into like the buzzwords first or the implementation first. As to really why are you doing, why would you model domains in this way or why would you use this kind of stuff? So I'll say, it's a really great book and I highly recommend it to the audience.
Oh, thanks very much.
And I just wondered kind of like, there's the book process. You've obviously got your blog and everything. And it'd be really interesting to know, like, how different did you find to write a book that focused on, those topics, those single topics, and, kind of in a lot more detail, probably. Well, I suppose you do go into a lot of detail, in your articles and stuff. But I was just wondering kind of, how is it different?
Yeah, it's interesting. I mean, some of my blog posts are pretty much like book length already. So, it's not the length so much as, for me, I mean, as part of the book writing process, you have to write an outline when you make the proposal to the publisher. So you make an outline, and it changed over time, but it ended up pretty much what my outline was like. It didn't change that much. And a lot of the material I'd already covered in various aspects in my talks and in the blog. So there wasn't too much. I mean, I had to write new examples and stuff, but the concepts, the way of explaining the concepts, I mostly had that written. Yeah, the hard part of writing a book is you have to write it. It's a linear thing. And especially if you're using a print version, you can't like Google things halfway through. So you have to write, the hardest thing is deciding what order do you talk about things? So you say, well, in order to talk about this, you need to explain this, but in order to explain this, you need to explain this other thing too. And often there's a kind of a loop or a cycle, and trying to decide what you explain first and how much detail you explain it.
You can go down the rabbit hole, I'm sure, and yak shave it.
Exactly. So, I mean, I try to have a minimal summary, basically everything you need to know to read. A good example for just talking about functional programming. There's many, many things I could have talked about. I tried to actually just have the absolute minimum that you needed to understand the rest of the book. So there wasn't all the complicated things that you can do and all the cool things you can do in F#, for example. I didn't hardly talk about some of that stuff. I just talked about the absolute basics of functional programming, because I'm assuming that the people who are coming to this book are going to be beginners in functional programming as well as beginners in domain-driven design. So I didn't want to overwhelm them with too much stuff. I mean, funny enough, the number one, one of the other big challenges was keeping the book short. The publisher, people don't really, in their experience, people don't really want to read 1,000-page tomes. It turns out that 200 or 300 pages is about as much as people really want to read. So trying to keep everything under 300 pages was actually a real challenge for me, because I like to write. It's like, well, I haven't talked about this thing and I haven't talked about this thing. It's like, I'll just have to live without it, And people can find more. There's more information on the internet, of course, if you get into it. So it's really, again, it was just trying to get an overview, get people excited about the topic, get people familiar with some of the concepts, but not go into too much detail. Then they can always go into more detail if they get into it later on,
Absolutely. I can imagine it's the focus and trying to make a holistic book that can kind of just stand on its own.
Yeah, and the other thing with the book is especially with a print edition. I mean, the book is going to come out it's already in the ebook is already available, and the print is coming out in a couple of weeks. With a print one, you realize that hopefully it will have a lifetime of maybe a couple of years at least. It's not going to be like Visual Basic 4.5. What's new? Those books don't last. Or what's the latest JavaScript framework? Those things have a very short shelf time. What I'd like to do is have this book have a shelf time of, like the domain-driven design book, the original one, that was published in the early 2000s and it's still selling very well, or the design patterns book, So ideally, the book would be around for, 2 or 3 years.
You mentioned you did a talk with Scott Nimrod as well. You mentioned the fact that trying to keep it down to 300 pages is a hard task. And I suppose, that kind of leads on to, is there another book in you? Like, did you think, maybe this kind of would lead on to another topic, or would you like to do a completely different topic?
Well, for a long time, I've been promising a book based on my blog, which I'm calling Understanding Functional Programming. And it's meant to be, again, a beginner's book, but it's all about, not domain-driven design, but just concepts behind functional programming. And it would go into a lot more detail on how just even getting started, and it would have exercises, and it would basically cover everything from soup to nuts from functional programming, but in my usual inimitable fashion with lots of little diagrams and pictures and stuff. Yeah, very unlike the kind of academic, there's not that many beginner books on functional programming which don't come across as kind of academic or kind of, even though they try to be, sometimes you get these books where they try to be fun by having funny analogies, funny examples and stuff, but the content itself is still hard to understand.
The burrito is one of them.
Yeah, exactly. It's no point trying to talk about burritos. That doesn't actually help you understand anything.
No, it suckers you in to think, oh, this may be something that's applicable and this analogy will work. And
exactly. So I do actually try and talk about the real concepts, but I try to use pictures and I try to demystify it as much as I can. So I think that would be a useful book. I've been promising it for a long time and I'm very lazy about getting it done. One of the advantages of actually having a contract with a proper publisher is the editor will then nag you. and they will nag you.
You could oblige then to
they'll ruthlessly call you up and say, "Where's the next chapter?" And that's good for me. I mean, I'm very bad at deadlines, so having someone nag you a lot is actually just what I need to get something finished.
And I suppose it also makes you then, yeah, exactly. You can't really pine over thinking, right, well, I want to add this, You have to deadline. This is what it is.
Yeah, exactly. I mean, you can't. It's very easy to. I mean, a lot of people would like to go over and over and never quite finish it. And yeah, again, having an editor say, "Okay, that's it. You're done. Next chapter, please," and that's it. So
tear you away from the last chapter.
Yeah.
It's like, no, you've got to focus on that now.
Although, I mean, I did actually get a chance to rewrite the first chapters. I mean, typically when you write something, you don't really understand what you've done until you reach the end, and you need to go back and rewrite the beginning. So I did actually do that. After I got about 2/3 of the way through the book, I realized that I needed to tweak my example, make it a little simpler, and just rewrite some of the code and rewrite some of the explanations. So it ended up being a kind of consistent whole. I'm glad I got a chance to do that, because otherwise it would have been quite different between the beginning and the end.
It's a long journey, because how long did the process take then to actually write the book, from like kind of conceiving the idea to actually the end result?
Pretty much a year. And that was just because I'm writing it, in between doing other things. So yeah, there's 13 chapters. So each chapter would take about 3 weeks or so. And so, yeah, pretty much just over a year between starting it and handing it into the editor and saying it's done.
That's not a bad turnaround at all. And one part actually of the pragmatic programmers, the other thing I like about them is they've got like a beta system. And it'd be really interesting to know, like, kind of from your point of view, like how you felt that, that helped, that aid, and also how that you feel it changed the book. Kind of, you're not in your own little microcosm of just writing a book and then releasing it. You've kind of got that feedback throughout.
Yeah, I think the feedback is really useful. There was also a reviewer thing where we sent the book out to a bunch of people who we knew, who would give us feedback who'd read it carefully and give us feedback. That feedback was actually very useful, and especially things like which things need to be explained more. This bit's too complicated. This doesn't make sense. That kind of feedback is fantastic. Didn't get so much feedback from the kind of public early access thing, just because probably not. There's not a massive amount of publicity. I wasn't really trying to publicize at that point because I didn't really want people to read it, to be honest, because it was a little bit of a mess, But there was some good questions. There is a public forum where people can post questions, and I did answer all those questions. And there were some good ones there too, which I did actually integrate some of those into the book. So yeah, I think writing a book, the best thing is actually to get feedback from someone who's actually will read the book cover to cover and give you, who you trust will give you feedback. So whether it's a public process or just your friends or something, either way, it's very, very useful.
And I suppose it must be interesting actually kind of like dipping your toe in and out then, because if you're doing other work, did you find that it took a little time to get yourself back into the groove of them writing again?
Yeah, it's hard. I mean, just writing is just like programming. You really need to get into the mindset, and it takes a long time to get kind of warmed up.
And it's very easy to drop it.
It's very easy to get distracted. I have to say, Twitter is a terrible thing. I mean, at some point, I actually thought about completely unplugging my internet altogether so that I just had no distractions. I can totally understand why a lot of writers actually on Twitter or Facebook or whatever, because it is incredibly distracting.
Yeah, and it's that kind of short little burst, isn't it, of like information and discussion, and it doesn't help towards the main goal that you've got, the objective of getting this book released.
Exactly. Yeah. I mean, when I did turn off the internet, I mean, it really helped, to focus. And and just like when you're programming, when you're writing, you can get into this flow state where all of a sudden 6 hours have gone by and you haven't even noticed. And that's good. That's what you want to aim for.
That's awesome. And it'd be really good actually to maybe like delve into the book a bit. As I say, I really recommend it to our audience. It is a really great read. But the beginning of it kind of, you discuss garbage in and garbage out and that rule. So I'm just wondering kind of what you mean by this.
Yeah, so it's the classic thing. If you no matter how good your system is, as developers, we tend to focus on the tools. Which language is the best language? What's the best compiler? What's the best tool chain? What's the best editor? And this is all about optimizing our personal process for writing code. But I think the whole thing about what gets lost in that is that if the input to your process is bad, the output is going to be bad. So if you have bad requirements, or if you don't understand the requirements, no matter how fantastic your tool set is, no matter how fantastic your language is, if the requirements are rubbish, the output's going to be rubbish. There's nothing you can do. I mean, it's just, there's no way around that. And so we tend to spend a lot of time focusing on our little bit of the workflow, as it were. And we don't spend enough time in my book focusing on understanding requirements, understanding what is the problem you're trying to solve. We have a tendency, a lot of us have a tendency to sort of dive in and start writing code, which is fine if you're writing a little script to do something. Obviously, that's perfect for that. But if you're trying to do kind of a major project, you can waste a lot of time writing code when you don't really understand what you're doing.
Why is that, do you think? Why is it because we're very introverted kind of generally as developers, or we like I suppose because we enjoy the programming side? It's really kind of the problem solving side that's our job.
Yeah, I think programmers like to solve problems. They just don't like to solve other people's problems, because what you have to do is you have to talk to people. And that's not something most programmers are that good at. And you have to have empathy for other people. It's not one of our strong points. We tend to, when you talk about somebody as a great coder, a great developer, you tend to think, they can write fantastically tight for loops and they can understand assembly or they can whatever. You never say, they really know how to interview a customer and find out what their business needs are. It's not a very trendy kind of skill to have. But in terms of having a successful project, if you're working on a team, like I say, if you're working on your own, fine, you can do whatever you like. But if you're working on a team and you're working for a business and they're paying you money to deliver something which is useful and valuable, part of your skill set should be that you can talk to other people and try and understand, what they want. And we often tend to be a little bit superior. It's like, well, those stupid people in the sales department, the stupid people in the marketing department, they don't understand anything. If they would just get out of the way and let me do it, I could just do it all myself and it'd be so much better. And, there's a little bit of that attitude. And I think that's actually something that as you get mature, you tend to realize that's not necessarily the best way of doing things.
Absolutely. Living on a hill, the problems you're trying to solve are their problems and they know a lot about what the problem is. You're just there to help provide a solution.
That's right. And that's why it's called domain-driven design, because the idea is they're the domain expert. They really understand what they want. And your job is to help them get what they want, not to tell them they're wrong. Often these people are very clever. They're not, just because they don't understand technical programming stuff doesn't mean they're stupid. And so they might not be able to express it in a way that makes sense from a programming point of view. And that's the whole point of sort of domain-driven design, is you get everyone the whole point is to try and get everyone on the same page. Developers tend to think in a certain way, domain experts really understand their domain, but they're not necessarily technical. Can we get everyone onto the same page, working with exactly the same mental model? If everyone can be thinking about the problem in the same way, then that's the idea. If you can do that, then the output, the code, is going to be much, much better that way. So that's all domain-driven design is. It's not any more complicated than that.
One of the things you did mention in the book is a Dan North talk, where he was saying how efficient, this business was. And it's because developers were essentially domain experts or becoming domain experts or, engrossed in the domain experts kind of world. And that's the way of being able to do it, is being able to, engross yourself in the problem.
Yeah, in that example, he was working and they were doing trading. They were working for a company that was doing trading. And that particular company sent all the developers off to be trained to be traders, just like the real traders. And as a result of that, the developers really, really understood the domain model. And when they were communicating with the traders, when the traders said, I want this kind of feature, they could totally understand what they were talking about because they understood the domain. I mean, and I remember when in my early days, I was working on an accounting program. And I did talk to one of the customers and he said, do you know anything about accounting? And I said, no. And he said, why are you working on an accounting program when you don't know anything about accounting? And it's like, yeah, that's a good question.
You can't really argue with that, can you?
And to be honest, the company I was working on, they probably should have sent us on an accounting training course so that we understood how accountants think. And then we would understand, and we'd understand all the accounting jargon, and we'd understand what was important to them and what wasn't important to them. And that would have been a much better use of our time. I mean, it would have taken a couple of weeks out of our schedule, but to me, that would have been a much bigger benefit, because that was a classic example where we would spend 6 months coding something and we'd deliver it and the customers hated it.
The garbage in, garbage out rule.
Yeah, because they say, well, it doesn't do this. I mean, how come, this is an accounting program, but how come you can't do this and how come you can't do that? Well, we didn't realize that's what you wanted.
And it's also empathizing with the domain experts, isn't it? And doing that, engrossing yourself in that problem really allows you to see where those problems are and how they affect people.
Absolutely. Empathy is a massively important skill. It doesn't mean you have to agree with people, but it doesn't mean you have to understand where they're coming from. And again, I think trying to understand what people want and trying to interpret what they want is an incredibly valuable skill. And I think people who can do that, that's one of the most important skills you can have if you're trying to create useful programs.
Absolutely. And moving on then to domain-driven design then, DDD, it's had quite a short history, really. You mentioned that the Blue Book from Eric Evans, it came out in the early 2000s. I suppose actually that's a long time, actually, if you really think about it in development world, but kind of, in the grand scheme of things.
In internet years, remember, it's like dog years. one internet year is like 7 normal years. So that was like 100 years ago. That book.
Good point, actually. Yeah, so 100 years ago, this book came out. And I'm just wondering, when did you first get introduced to domain-driven design, and how has it influenced you? And actually, what kind of is its goal?
Well, I think I was into it not so long after it came out, maybe about 10, at least certainly more than 10 years ago. And because I like to read, I like to read lots of books. And it definitely, to me, it made total sense, the concepts. Eric has said that since then he would have actually written the book in the backwards because some of the most important concepts are sort of the end of the book. But it totally meshed with my personal experience because I had, again, when I was a much younger developer, one of the things that turned me into somebody who would be more empathetic with the customers was doing usability testing. And we would take our product and we would show it to the users and they would not be able to do anything. And we'd be behind this window screaming at them saying, it's so obvious. You just do Control-Alt-Delete, or it's like var, you do the, colon QW bang. And I don't see why people can't understand that anyway. So that again, it really helped me to understand that users, they need usability. Usability is important. User experience is very important, and domain-driven design fits nicely into that. If you're into user experience, domain-driven design is just the sort of developer version of that. So it's to me, it's a great thing, and so it's sort of what I've been doing anyway. Whenever I come across a new project, I really do like to spend a couple of weeks really trying to understand the domain. Now, I might, if I was writing an accounting program now, I would buy a book on accounting and read it, because I would try to understand what they're talking about. And I would talk to the customer and say, let me make sure I understand what you want before I spend 6 months going away and coding it, And the other thing, it fits very well into, agile models. Anything where you have anything, you don't have to call it agile, but anything with a fast feedback loop, right? If you just go away for 6 months or a year and write something, that's a recipe for disaster. Really, you want to be talking to people, showing them something, every week, every few weeks at the latest. And that equally applies to domain modeling. So rather than listening to them and then writing up a requirements document, a 500-page requirements document, and then getting them to sign off on that document in 6 months, if you say, well, here's a page of here's my understanding of what you want. Here's one page. Can you just review this page and make sure it makes sense? And
they were both on the same wavelength.
Yeah, and then you just do that over and over. That's the feedback loop right there. And that should be a very fast feedback loop if you do that right.
Absolutely. And there you actually mentioned then kind of like the distance between those domain experts, so the people with the knowledge of that domain, and the development process and the developers. There is that obviously process of having a domain spec, sheet, technical outline, sign it off, and then, it goes through and it goes off into this room where they magically make a product and it's released, and it could be completely, different to what it is. How does this actually help then? Is it really then that you are, that developer is actually talking to that domain expert, that person sitting with them and getting involved?
Yes, I have a little diagram in the book, which is a classic kind of waterfall model. Well, not even a waterfall model, but any model where it's the game, what we call Chinese whispers in England and what Americans call telephone. You start by saying something, and then they they pass it on to somebody else, and they pass it on to somebody else, and they pass it on to somebody else. By the time it gets to the other person, it's been completely distorted, and that's funny when it's a children's game, but when it's like a business requirements process,
with a lot of money behind it, yeah.
Exactly. It's a disaster. And so bringing the domain expert and bringing everybody together in the same room to talk about stuff. It's about communication. You need to be in the same room, or at least, on the same Skype call. But the more direct communication you have you can have between people, the less likely there's going to be communication problems. I mean, it's obvious, it's really common sense, but it's surprisingly, like most common sense, it's surprising how uncommon it is in practice,
And I think it is the personalities, isn't it, of the people involved. They prefer, they prefer a reference guide to Visual Basic, than a soft skills of actually talking to people, as opposed to trying to learn and understand how people work. So I know that was one thing actually you spoke about last episode, where it's like you enjoy the psychology and you enjoy more about how people work and how systems are actually formed and things like that. And that's kind of a real soft skill, as opposed to these hard skills of, trying to learn programming and learning the latest language and the latest concepts.
Yeah, and I mean, this concept of hard and soft skills, I find that a bit dodgy, actually.
It is, I suppose it is, isn't it? Because you're saying a soft skill is it's a weak skill. It's not. It's as important.
Yeah, if anything, I'd rather have someone who was good at understanding the customer and was a bad programmer, a so-called bad programmer, using Visual Basic, than, someone who's like a C++ experts who can't understand, I mean, I do actually think that's actually a more valuable skill. I mean, there are some situations where pure coding skill is really important. If you're doing very algorithmic work, if you're writing a device driver, or you're writing a video codec, or, you're writing the Google's big table or something like that. That's very technical stuff. You're not really talking to anybody outside world. You're implementing complicated algorithms. It's all about efficiency and performance and stuff. That's fine. The kind of stuff I'm talking about is, enterprise development or business focused development, where you're dealing with non-technical people, and the requirements tend to be very fuzzy. Again, you're not implementing a particular algorithm. You're actually trying to understand half the problem is trying to understand what people want, and that is actually half the challenge right there. So the actual development process is the least of your worries, And if you look at all the IT failures, I mean, there's it's well known. There's lots of major companies and governments and stuff have all these IT projects. I mean, half of them end up as failures, and it's not because I don't think it's because the people are bad programmers. It's because, again, there's probably mixed messages about the requirements. There's a lot of other stuff going on, and that's really what causes projects to have problems. It's very rarely can you blame it on the programming language.
I think communication is key, isn't it?
Absolutely, yeah.
And so, you mentioned in the book, when you go to DDD, you see a lot of buzzwords and a lot of things that and I think, again, this kind of comes from our personalities developers. We talk a lot more about like implementation details of things like repositories and aggregate routes and stuff. And it would be great maybe to touch upon some of those. But a key concept is the shared model. And what actually then is a model?
Well, you need to have some way of thinking about something. I mean, the real world is really, really complicated. And so when you're building something, when we build software, we're building a model of the real world. We're not actually we can't possibly build the real world. So we have to decide to pick and choose what's important. So that's what I would call the model. And there's even multiple models. There's the model of the real world, which is a simplified version of the real world. And then there's the model, the domain model or the design model, which is what the code does. And that's an even more simplified version of the problem model. So they're all the model, just like in a model railway or a model car or something. The important part is to keep the important things the same, is to really model the important stuff and to not bothering model all the stuff which is not important, because nobody cares about that.
And that comes down to communication and distilling it the right way.
Exactly. How do you know what's important? Yeah. Who decides what's important? Again, one of the classic problems in a lot of systems that have failures is that they try to model everything. You try and capture the entire messiness of the real world. And that's a recipe for disaster too, because 10 years later, you're still programming and you haven't actually got anything released,
That's it. You need to find the real parts that matter. And I really like that analogy, with, say, a model car or something. You're not modeling the engine in there. You're not, you're modeling the key characteristics that make up the car.
Yeah. And in different models, and also just like in our real world, different models for different things. If I'm having a model train, chances are that I want it to sort of look like the real train, but I don't care about that it's really got exactly the same kind of engine. But on hand, if I'm doing a physics experiment and I have a model of an engine, in that case, I want the engine model to replicate the real world thing as much as possible. So it might be a scaled down engine or a diesel engine, whatever it is. I don't know. But I mean, what's important for different situations is what you need to model. And that's one of the things in domain-driven design is don't try and model everything in one monolithic thing. You might need different models for different situations. And that's what the domain-driven design people call a bounded context. In this particular situation, you care about this kind of stuff, model that. And in this other situation, you care about this kind of stuff, model that. Don't try and have one model that tries to capture everything, because it's a recipe for disaster. And another common example of this is if you have a big company and you're trying to model what is a customer, and the marketing department thinks that a customer is anybody with an email address. Because they can send them email, and the billing department or the accounting department might think that a customer is somebody who has an account with them, who owes them money. Everyone has a different idea of what a customer is. Rather than trying to come up with a unified version of a customer that works for everybody across all departments, model it differently. Each department has a different idea of what a customer is. Then model that. You have a context for the billing team, and that's one kind of customer, and you have a context for the marketing team, and that's another kind of customer. And don't attempt to mix them up, because it's not going to work.
I think that's one of our problems, isn't it? And you could assume, maybe, okay, I need to, in say an MVC pattern, you'd have a model for a customer, and then you would chuck in all this kind of different context stuff into one model of a customer, where the rate of change and everything is so different for each of the different problems. But because in the code, that's the way it is, and the way people think about it is so different. Kind of representing then this model in source code, that is a very important aspect of it.
Absolutely. And one of the nice things about a functional language, this is where functional languages are really nice, because you can create in the functional version of domain modeling, you create a type that represents a customer. And in F#, for example, it's really easy to create new types. You can create hundreds of them, because they're very compact and they fit on one page. So you could easily create 20 different kinds of customers. And it literally takes a few minutes to do that. So there's very, very low overhead for doing that. Sometimes in some systems, it's a lot of overhead to create a new kind of thing. And therefore you tend to want to reuse it over and over. And then that's kind of where you get your problems coming from. So if you can just say, I need this particular situation, I need this kind of customer, I'm going to create a new type just to represent that kind of customer. It's like, fine, that's really easy. And what's nice about that is, this is where the types act as documentation, because you can look at that type and say, this is the type that's used, this is the billing customer, and I can see exactly what's important for billing. And it doesn't have any of the other stuff in there. And I can look at a shipping customer or an order taking customer or whatever it is. And they all have slightly different structures, and they're all specifically designed for that task. And I mean, you can see a lot of this in I think this is a general trend in development in general. The whole point of having, for example, command query separation. That's another example. You have different models for different things. Updating is a different kind of model from querying. Microservices. It's all, it's people are realizing that there's no trying to have one model fits all is not a good idea in general.
It's the GOG class problem, isn't it? And it's this idea that one place for everything. And I think it's probably how, as developers, we try and convert and communicate our problem that we have in the domain space with, say, a pattern or something, like, say, with MVC or something that, we're like, okay, yeah, well, that fits, and that fits well into, being in that model. And it's, as opposed to kind of considering, no, let's represent this problem holistically in source code, as opposed to trying to translate it into a pattern that we already see fit, that's going to be the solution to the problem.
Right. And I mean, one of the things about domain design that is emphasized is don't try and make your model fit a pattern that you think you already know. So I talk about in the book, database-driven design, and you say, as a developer, if you're a database person, you might say, well, I'm going to model this as a bunch of tables and a bunch of foreign keys and stuff. And as soon as you start doing that, you start saying, well, how could I make this table, how could I make this thing fit into a table? And you're trying to squeeze, it's a round peg in a square hole. And the same thing with object-oriented design. You say, well, how can I have a base class? It's like, oh, well, a customer is almost like an employee. Let me have a person base class that is like, no, don't do that. It's not necessary. Model each thing. And then from the domain, it's all about the domain. It's not about the implementation. So you model it the way it should be modeled, the way that a non-technical person would model it. I mean, of things like base classes, non-technical people don't understand base classes. They don't understand manager classes. They don't understand controllers and, all this stuff. It's like model it exactly like in exactly the way that you would talk to a normal person, a non-developer. And, if you're not modeling that way, your model is not very good.
It just makes the translation harder, doesn't it? Because you're then reading this source code and trying to then distill the concepts that you know as a developer into the domain problem that's completely different. It's just a completely different translation.
Exactly. So, obviously there is, you need to do technical stuff when you actually do store stuff in a database or something. You need to understand databases and stuff, but that's not part of your domain model. That's part of the implementation. And, ideally your implementation does not contaminate your domain model if you can help it.
Communications everywhere, and the idea of the ubiquitous language, is a big thing in domain-driven design. What exactly is the ubiquitous language?
It's just the language that you would use to make sure that everyone's on the same page. So if I use a word and you use the word in a different meaning, or you use a different word, we're going to have communication problems. So, for example, if you're doing a chemistry thing, you might say, a chemist might talk about a molecule, and you might talk, well, it's a linked list of atoms or something. It's like, no, it's not a linked list of atoms, it's a molecule. And just the fact that you're representing in your code in a certain way, that makes no sense to a chemist or a polymer or something. You need to use the same vocabulary that the domain experts use. And the idea is that if everyone can agree on the vocabulary, that's the ubiquitous language. That's the everywhere language. The same language is used in the domain and in the code. And that's the third part. So there's the developers and the development team. And when I say developers, I also mean anyone involved in development. So that includes testing and user interface people and stuff. So that's just to be clear, I'm not trying to exclude those other people who are very important. There's the third part. So you've got your technical people, you've got your domain experts, and the code is the sort of third leg. And one of the things about domain-driven design is to try and also have the code represent the domain directly. So if there's a concept called, molecule in the domain, you'd have a thing called a molecule in the code. You wouldn't call it a linked list in the code. The idea is you can look at the code and the domain is represented in the code using the same language, using the same concepts that the domain experts use. Or sometimes you may have to agree. Sometimes the domain experts may need to learn a bit of jargon from the technical people because you're building a technical system, so they may need to understand some of that stuff. But the point is, you all agree on the terminology, you all agree on the concepts, and that's all the ubiquitous language is. It's just everywhere. The important part of ubiquitous is it's everywhere language.
Yeah, because like one of the examples you actually said just earlier, the idea of a person. So you've made this person base class. You're talking about a base class of a person. When say, marketing's talking about a verified email address user, someone who's got a verified email address that I can email. The translation there is just so far stretched that you're going to have an external document to actually, or internal knowledge to understand that this is what this means, as opposed to trying to represent exactly what that problem is in the source code.
Right. I mean, there's a good example. Rather than having a person, if the marketing people say we need to have a person with a verified, a verified person or something, rather than saying it's a person and we're going to have a verified flag, we're going to create something called a verified person. That's a thing in the code. There'll be something, either a class or a type in the code called a verified person. And that's the same thing that the marketing people talk about. So all the behavior associated with that goes along with that thing. And we don't try and use flags and stuff. We try and create new things that represent things in the domain.
It is really just trying to make things easier, isn't it? For everyone.
It is. I mean, it's like I say, I think it's just common sense. It really does help if you can easily create hundreds of things. I mean, like I say, in F#, you can create hundreds and hundreds of types very, very easily. And I think if there's any kind of thing that slows you down, that blocks you, that's going to be a disincentive, and you end up with things like God classes where it's a kitchen sink and you put everything in there because it's too much extra work to create a new kind of class. And that's the problem with our tools, though. That's not, the domain modeling tries to say, don't do that. And so it's always a way of forcing. If you have a God class, it's like it obviously doesn't match the domain model. So domain modeling will help you refactor your code if you've got code like that already.
Yeah, it's just kind of merging many bounded context, things into one that you then have to kind of try and get a lens on for different bits based on the problems. And you say it's too far down into a development kind of implementation problem.
Exactly, yeah.
And, one thing actually there, so we've already touched on a little bit, but kind of the concept of the problem space and the solution space and kind of how they differ. I'm just wondering kind of, you mentioned in the book, the problem space and the solution space. Would you mind kind of explaining that a little bit more?
Yeah, but well, again, when the real world is messy and complicated and the programming world tends to be clean and we try to avoid messiness when we write code because it makes it very hard to maintain. But as soon as you make something clean, it's going to be different from the real world. And real world things overlap. You don't have these perfect non-intersecting domains where nobody talks to each other. In the real world, things are very fuzzy. In the code, you actually want the opposite of fuzzy. You want very crisp boundaries. You want to have, very clear contracts between the different components in the system and so on. In the real world, those kinds of things don't exist. So there's going to be a distinction between the problem space when your understanding of how it works in the real world versus how you implement it. And so, again, as part of your design, you're going to have to say, well, where are the boundaries? And that's a really important decision. In the real world, you don't have to make that decision so much because they're fuzzy. And there is, but when you come to your solution, you're going to have to say, okay, the shipping module is going to be completely different from the billing module, and they're going to talk through this particular API, and I've got to define what that API is, and if I change that contract, that's going to be painful, and that stuff it doesn't exist in the real world, but it's something that's very important for your model before you start coding. That stuff has to exist before you start writing code.
At an implementation detail there, like how do these bounding contexts actually communicate with each other?
Well, that depends. That is an implementation detail. I think what's really important is to have the bounded context and to have this modular system. Now, whether they exist as a monolith, where they're all in the same process, or whether they exist as separate services like classic SOA, or whether they exist as microservices, that is, to me, much more of an implementation detail. That's the physical deployment model as opposed to the logical model. And if you get your boundaries right, you can mix and match. I mean, they could talk to each other. If they're in the same process, they can just talk to each other through a method call or a function call, or you could have like an in-memory queue. If they're in deployed physically different, then you might need, either some sort of external message queue or whatever, some way to talk to them. Typically, it's an asynchronous communication. You don't want to be, especially if they're literally remote from each other, you don't want to have direct communication. You don't want to have RPC calls. You want to have an asynchronous call. So it's basically a message queues are typically the best way of doing that kind of thing.
And it's interesting because, have you found that obviously a bounding context can be, within the same process, but have you found that it's actually more beneficial and less likely to violation if they are separate microservices or separate systems altogether?
No. I actually like monoliths. I'm a fan of monoliths. I think there's a lot of hype over microservices. I think, obviously, I don't like big balls of mud. I think the design skills of partitioning a monolith, partitioning code into modules that communicate independently, that is a key skill, and that's the most important thing. It's true that in a monolith you can there's backdoors to doing things. You can cheat, but there are always ways you can define APIs that way you can't cheat. I mean, if they're for example, in .NET, you can define different assemblies and they have public interfaces and you can only access them through the public interfaces. So there's an example of a kind of monolithic deployment, but the assemblies are, logically independent. And they have a logical interface that you have to communicate through. And so you can't, there's always backdoors for anything. But if you design your code that way, it kind of forces you into good habits. But you have to want to design your code that way. I think the whole thing about microservices, they're using the physical deployment as a crutch to force them to do logical partitioning.
Because they physically can't change it, can they? Like, it's like, I actually can't do that, as opposed to, a mental separation.
So rather than saying, I'm not allowed to look inside this other module, it's like, well, let me put this code on a completely different server, and then I definitely can't look inside it. You end up with microservices spaghetti as well. I mean, just because they're physically deployed in, separately, you just absolutely get spaghetti. You still get masses of dependencies and things where they depend on each other. And if you deploy one, if one of them changes, they all fall down. You can get big balls of mud big balls and mud's a logical thing and not a physical thing, you know.
It's actually easier in a monolith to actually comprehend a change because you can see it all there. It's in maybe one repository, or something like that, as opposed to this separation where you've got this, very much like everything's separated, everything's in its own world. You don't actually know what's happening until you run you run it in production.
Yeah, I mean, like I say, I like monoliths because, yeah, you can, especially if you have a strict type system, you can define your contracts in a very strict way. And then if you create a new contract between components and you change that contract, everything breaks until you fix it. When you have JSON contracts, it's quite easy to have things where things break and you don't know until you've deployed it. And I mean, saying you have to do a lot of testing. I think I'm saying I'm not down on microservices 100%. I think they're great for people who need them. And if you need to scale these things independently, if you have that much scale, if you're Twitter or Google or something, Facebook, fine. Most enterprise things I've worked at, if you have a couple of hundred transactions a minute, that's a lot. If you're doing, most people do not need web scale. I think it's one of those things like, I want to be Google. I need to handle 10,000 transactions a second. It's like, I don't think you do. Maybe you do, in which case, good. A decent powered server can handle, hundreds of transactions a second. That's normally fine for most people. It's very rare that if you're one of the people who need that, that's fine. But like I say, in most businesses and most enterprises, it's unusual that you need more than that.
It was one actually interesting thing because you mentioned how, you've kind of been thinking a lot along the DDD route, even prior to the book. I'm just wondering kind of, when the book came out, I suppose it was a realization to you that exactly what you'd been thinking. Like, had you kind of incorporated certain bits and aspects into your kind of, developer life before the book came out? Or did that really help spear that on and say, right, I'm going to use this in practice?
I think, yeah, what it did is just like most good books, it could have put a name to things that were sort of in the air, and just like the whole agile movement did, and just like XP did, and so on. There's these things kind of floating around, and Eric Evans did a great job of sort of nailing it down and saying giving things names can actually be a really useful way of helping progress. As soon as you have a label to put with a concept, that can actually be very helpful. And he did a great job with all that stuff. I think, obviously that was written then, and I think if he was going to rewrite it now, he'd probably write it in a different way. But at the time, it was very, very useful. Yeah.
Do you find, and this is, I suppose, a very much developer-centric thing, that people get caught up in the patterns and the concepts more so than the philosophy? Yeah,
I mean, as we all do, we obsess about patterns. It's like, and I think, and that's one of Eric Evans' regrets about the book, is people did focus on on the patterns, and he did put the sort of philosophy at the end. To me, the philosophy of DDD, I mean, this is my interpretation, because I wouldn't say I'm an expert on DDD, but in my interpretation, it's about communication. It's about a shared model. It's about getting everyone on the same page and making the code be on the same, not just the people, but the code is also on the same page. So the model in the code, the model that the developers use, the model that the domain experts use, is all the same thing. And that's the best way to have success. Now, there's obviously ways to get there. So there's some jargon, there's some concepts that help. So, ubiquitous language is a bit of jargon. The bounded context is a bit of jargon. These are labels to help you understand concepts that help you get there. But to me, the most basic part is, the shared model, and everything else sort of falls from that. Some of these patterns, I mean, people spent hours, days arguing about, well, what's the best way to implement a repository pattern, or, what's the difference between an aggregate? Is this an aggregate? Is this an entity? There's a lot of stuff. And I mean, that's, I'm not saying that's terribly unimportant, but it is. People say, well, give me an example of domain-driven design. It's a process. It's not an example. I mean, you can't really say, here, follow this recipe.
You can't just say, give me the code. Where's the code and, the pattern and then a definition of that pattern for me to reuse. It's not
a cookbook. It's like user experience things. The same thing. You need to listen. You can't just say this is the right way to do it in all contexts. It's all about listening and doing what makes sense in your context, and also getting feedback. Again, not just listening once, but listening over and over again and changing based on the feedback. If you look at a lot of the agile people are very interested in the Toyota's model for doing manufacturing, the Toyota Kata and all that stuff. If you look at how they actually do, they don't have these rigid recipes. They have things like, well, here's a process, and the process has a feedback loop in it. And if the process isn't working, you feedback and you change the process. There's not a strict model that you have to follow that says this is exactly the right way to do it and this is the only way to do it.
No, brilliant. And maybe going a little bit against that now, where I start asking maybe about some of the actual implementation concepts, if that's okay, and maybe having some definitions to them. I know I'm going completely against, saying it, because that is true, though. The philosophy is the main part. I'm just wondering kind of, what is an entity and a value object?
Yeah, I think what the way I introduce it in the book is like when you've done a bunch of domain models, you start noticing certain patterns. Certain things show up over and over again. And one of the things that shows up is the difference between things that have identity and things that don't have identity. So if I talk about, an address in English, we would say, well, my address is the same as your address. And that means even though my address is, my record, my data structure is technically different from your data structure, we call them the same thing because they have the same properties, they have the same fields, and there's no identity. It's not like my address is different from your address because it's mine, Then that doesn't make sense for things like addresses and names, email, all that stuff. They're the same no matter. Money is another one. It doesn't matter who has them. It's the same thing, right? Now, there are other things which have identity. So, for example, if I am drinking a cup of tea and you have a cup of tea, this is my cup of tea. You don't want to be drinking out of my cup, right? They have identity. They're different. So they might have started off as the same cup, as different kinds of cup, as equal. But as soon as we start using them, they have an identity, and they no longer should be mixed up, even though they're technically, from some point of view, they might be the same thing. They're in the same cup, they have the same liquid, but one's mine, one's yours. At that point, they have an identity, and they need to be kept separate. And at that point, you give them an identifier, some kind of identifier. Sometimes the identifier is built in, but sometimes the identifier is human imposed. We have to give them a number or a code or something. And that's the difference between a value object and an entity. An entity is something that has an identity, and value object is something that doesn't. So an address, a name, there's money, these are all value objects, but a customer, an order, a product, those are all entities. They have an ID that makes them unique from two people who have the same name and the same address might not be the same person, right? They could be siblings or something, or so they have an identity. And even if you change one of the properties, even if you change your name, even if you change your address, you're still the same person. You have an identity that is persistent through different, even if as your properties change, you're still the same person. So that's a key thing. And that leads me to, so that's obviously that's like a really obvious pattern when you're doing domain modeling. So Eric Evans gave those things names, entity type of thing and a value object type of thing. And then I also go into the book about state transitions, because I think in most business processes, certainly things, you have an order. There's a process, and you start with like an unvalidated order, and then it's validated, and then it's priced, and then it's transformed into something else. Then it might be shipped, and it might be billed. It's like there's these different stages it goes through, and there's a state transition all the way through. And one of the things I talk about in the book is, I think state transitions are a great way of modeling changes in an entity as it goes through a life cycle.
And then, like a language such as F#, and Marista actually not asked this, like how does that help, in modeling these concepts such as entities and value objects, as opposed to say like an OO language like Java?
Well, one of the things in functional languages, normally things with the same properties are the same thing, are equal. So in Java and C#, if you want to have an address object where two addresses are the same, if they have the same street and the same city or whatever, that requires writing code to do that, because in an object-oriented model, identity is every object has its own identity. So you have to go to extra work to override that. In a functional language, things are assumed to be the same unless they don't have different identities. They tend to have everything's a value object in a functional language, sort of by default. And so entities are the special case. So that's one of the things about, using a functional language like F#.
Going back a bit to bounded context, another buzzword, another buzz term is anti-corruption layers. I'm just wondering, could you maybe distill that down a little bit to actually what it means?
Yeah. So obviously in the design, you have this kind of nice domain, you have this outside world. When things come in and out of the domain, there's obviously some sort of validation process to check that the data is valid. But on top of that, you might want to make sure that your domain model is not corrupted by somebody else's domain model. And that typically happens when you interface either with another domain or a third-party service. In the example of my book, I say, let's say you're going to a third-party service that does address validation. Well, they have a certain model of what addresses look like. Now, when you interface with that service, you can say, I could either try and make my code match their model, in which case my code has been adapted to fit that particular design. But now we've got coupling, because if I ever go to a different service, they might not use the same model. If I write an anti-corruption layer, that's going to basically say, it's going to protect my model from changes in their model. You think of it in linguistically, it's translating from one domain, from one language to another language. And it just makes sure that things, again, decoupling, domain-driven design, a lot of it is also about decoupling. How can you make sure that things can evolve independently? And this is a good insight, I think, is that in the real world, things do evolve independently. Eric likes to use the analogy of, a three-legged race. If two people are tied together, it's really hard for them to run, even walk, right? They're not going to get very far. If people are free to move independently, if they're not tied together, they can actually go in different directions and they can go at different speeds and they can, So autonomy is a really, really important concept. And making sure that each module is autonomous and can evolve at its own speed and can evolve in its own direction is a really key thing. So if models are tied together, if different domains are sort of joined at the hip and they rely on the same concepts, that's going to prevent them from being autonomous. So something like an anti-corruption layer is a tool that allows you to, keep that autonomy and you don't become dependent on some other system.
Following on from that, another one, the buzz term that you'll see around is aggregates and aggregate roots. And I'm just wondering, how do they maintain the invariants within a system or within a concept?
Yeah, so there's another example of a pattern that shows up over and over in when you're doing domain modeling. You have certain consistency boundaries that you need to maintain. So an example I use in the book is when you update the price of an item in an order, you might need to update the total price as well if you're going to store that as a separate field. And that means you need to update two things at the same time and make sure they stay in sync. And for that to work, you're going to have somebody who has to manage a kind of parent object that keeps track of everything. It's basically a micro boundary, so that when I say update the price of this item, it doesn't just do that thing, but it also updates the order total and makes sure that they are in sync. And so that's what an aggregate is. It's basically a little micro domain that ensures consistency within it. And an aggregate is typically the top level entity. So in an order, you might have a bunch of order lines or some other stuff. The order is going to be your aggregate, or the customer is going to be your aggregate, even though there might be other things inside it. So, and the aggregate root is just basically the top level item in this kind of little micro domain. And the idea in that is everything goes through that. So if I want to change the price of an order line, I don't edit the order line directly. I always have to go through the top level, through the order, because the order is the only thing that understands what else needs to change to keep things consistent. And if you're doing database transactions, again, it's the unit of database transactions. So if I have an order and a bunch of order lines, I can't just save the order lines independently. I have to save the order lines and the order and everything else in one single database transaction to make sure it stays consistent.
The unit of work.
It's a unit of work, exactly, yeah.
And that's, because that's again the modeling of you're modeling the real world there, and you can't just reference things kind of ad hoc. That's how the real world and that domain actually works. Yeah,
it's a little bit artificial, because in the real world, I might just have a piece of paper. And in the real world, we tend to get a lot more consistency errors. It's quite easy in the real world for me to change a line on a piece of paper and forget to change the total. And so one of the reasons for putting that in a computer is to actually have these consistency checks. In theory, you'd be less likely to have stupid errors like that in a computer version than you are in a paper version. Not necessarily true, but that's the theory anyway.
And I suppose that's the key to the mapping between the problem space and the solution space, is that you are going to be adding, say, anti-corruption layers and things such as this, this invariance within the solution space that may not be present in the problem space.
Exactly. These are things you have to do. I mean, this is why this is not domain-driven design. This is domain-driven implementation. This is how you have to model things on the implementation side of things in order to get certain things to happen. I'm a very big fan of using bits of paper as an analogy, because in the real world, people are very comfortable with working with bits of paper. It's very transparent. You can see, everything that's happened. So I think, as much as possible, trying to have that same kind of transparency for the digital model is a great goal.
And it'd be really interesting, actually, from your past experience, like kind of how much success have you had with DDD? Going into, maybe starting off a project with it, or having to go into a project that began with DDD and how they've, implemented it. What's been your experience?
Yeah, I mean, not necessarily using DDD as a formal process, but in terms of just listening to the customers. I mean, I did take over. There's a couple of times where I've taken over sort of a failing project, and one I did a while ago where they'd been working on it for a year, but its thing is the developers is a very hands-off thing. They'd had these requirements documents and so on, and I started meeting with the customers every week and finding out what they wanted, and then giving them a prototype the following week, and again trying to make the things in the code. If they talked about a certain kind of thing, I'd try and have a class that had exactly that kind of thing, and that worked out really well. I mean, we accomplished more in a couple of months than they had done in a year before that. So, to me, every time I've done it, it's been a successful process. And I mean, I didn't used to do it, and I've learned from my mistakes, hopefully. I don't think, like I said, I don't think it's a heavyweight process. I don't think it's something that requires, a process around it. It's just something you do, talking to people, trying to have have the same shared model and try and make the code capture that model. It's like, to me, that's common sense. It doesn't actually take any longer. I think some people say, well, all the time I'm talking to people, I could be writing code. And this thing of a couple of months of coding can save you weeks of planning, And so that's the classic thing, is like, sometimes talking to people can actually save you a lot of time.
Do you find then that one of the gotchas with it is then the fact that people, obviously, they get too tied to the repositories, domain services, aggregate routes, value objects? And because I think, everyone can understand talking to the customer, delving into the problem space is a very valuable thing to have and do. But do you find that people do it for the inverse, and they're like, okay, I'm going to chuck a value object here, I'm going to do an entity here, aggregate route here because I have to or want to, as opposed to, okay, what does the problem really require?
Yeah, I think just giving names to things doesn't solve the problem. And talking about, the jargon, people get caught up in the jargon, and it's a shame in a way that there is this jargon, because it is a little bit off-putting. Yeah, it's a useful concept if you understand. It's a way of categorizing things, which is helpful, but it's not the point is the usefulness comes first and the jargon comes second.
But as developers, we like the jargon. I think that's the problem, isn't it? We like the pattern, we like the name.
Yeah, and it's a crutch for us to avoid dealing with important issues like talking to people.
That's exactly it. I was going to say, yeah, that is exactly. Almost make ourselves more important. The fact that, you don't know what an entity is, or you don't know what this is. This is, my world that I'm living in.
That's right. I mean, and I could talk for hours on this, because another good example of exactly this thing is functional programming jargon versus solving problems. And Rich Hickey, Closure person, had a talk recently where he said that typed languages do not actually help solve problems. And he obviously got a lot of pushback from the functional programming, from the statically typed functional programming people, the Haskell people and so on, saying he didn't understand types and da-da-da-da. And I think a lot of people misunderstood what he was saying. And I actually sort of agree with him, which is that, your language doesn't solve problems. If you look at the most successful companies, they're not using Haskell, they're using PHP. So you say, well, how can that be if PHP is such a terrible language? And once you answer that question, then you can understand maybe why those companies are successful. So I just think we have to be, I do like functional programming, and I do like statically typed thing, and I can talk about monads, like if you want to, but to me, that's actually not solving the problem. It's a tool to help you. In this particular case, statically typed language is a great way to ensure correctness. Having a correct solution to the wrong problem is not very helpful. Again, you need to understand it's the garbage in, garbage out. The statically typed languages can really help you ensure that you implement the requirements correctly, but they can't ensure that the requirements are correct in the first place.
How do developers, learn the art of communication and things like that? Is it more delving into psychology of things and understanding people and understanding spaces and what questions to ask, etc.?
Yeah, I think my book that had a big influence on me was Don Norman's Design of Everyday Things, which came out in the 90s, mid-90s, early 90s, I think. And, again, trying to design things, there's a philosophy of design that there's a mental people have mental models of things. And if you don't design something that matches their mental model, they get very upset and confused. That was very important. I've always been interested in user interface design. So if you read various people who are big on user experience, Alan Cooper, for example, called About Face. These are books from the 90s when I was getting started, so they might be a little out of date. Another one was things like Crossing the Chasm. Some of these business books about how do you Crossing the Chasm is a kind of business version of the Diffusion of Innovation, which is sort of a technical book. But it's all about, you have this fantastic idea, but how do you get the mainstream to get interested in it? And that's what he called Crossing the Chasm. There's this kind of chasm between the early adopters and the mainstream. And you can't just, you get very frustrated where it's like you have this fantastic idea and nobody wants to use it. Some people really like it, but the rest of the people are just not interested. And you tend to blame people for being stupid, but
that's exactly it. It's like, you don't understand this. You're not good enough. Yeah, you just don't understand how good this is. But it's really because you haven't found a way of letting them understand or getting to a level where they're actually useful or beneficial to them.
So, these books, like I say, I think they're just, they might be a little bit out of date, but I think there's a lot of good, valuable concepts. And there's many of the kind of business intersection. Some of the business, I think, programmers should read business books, or not necessarily, how to get rich quick types of books, but how businesses work internally and the various issues that businesses have adopting new technology. Another one was The Innovator's Dilemma. That's a great book. Again, if you have a big company, why won't they adopt new technology when it's so obviously better than the old technology? That kind of thing. It's very useful to understand that they're not just being irrational. They're not being irrational and stupid. They have very good reasons for doing that.
And this is what aims to success. This is what gets, our code into something that's actually, worthwhile and solves the problem, which as a developer, that's what you hope to do. You hope to be a problem solver. You can't woo people with the fact that you're using a monad. A lot of people don't care about that. So you have to work out why and the psychology behind it, that system's working and that system's not.
Absolutely. And again, some developers don't care about that, and that's fine. If you want to work on kind of back-end stuff and algorithmic stuff, that's fine. But if you're working in a business environment, which I think 99% of developers are, that's basically what most people do in our day job. That pays the rent, and it behooves you to understand how businesses work. It's not always a one-way street where you expect them to understand technical stuff. You need to understand non-technical stuff to become a better developer.
Absolutely. And they're the important one, I think, is another thing. You are not the important one in that story. Their problem is the important problem.
It's what I always say is follow the money. Typically businesses, like the departments that make money, tend to get a lot of attention, and that's sales and marketing, sales especially. IT is considered a cost center, and so you're never going to get any attention from the business unless you can make them money,
So true. Scott, well, thank you so much again, man, for coming on the show. I really appreciate it. It's always, great chatting to you about all this stuff.
It's my pleasure. Thanks so much.
Awesome. Well, I say we'll definitely have to do this again, because I know that you've recently had a talk and everything that you've done, a composition talk. So it'd be great to have you on sooner than later so we can discuss that.
Sure, that would be a great topic for a talk as well, for a chat as well.
All right then, audience. Well, it's been another great episode, and we'll speak to you again next week. Goodbye.
You've been listening to 3 Devs and a Maybe. You can contact us at contact@3devsandamaybe.com or follow us on Twitter at 3 Devs and a Maybe.